The next session is titled AI in Responsible Gaming, New Technological Solutions for an Age-Old Problem. Kim Mouridsen, founder of Mindway AI and professor at Aarhus University, will explain how technology can be harnessed to make our sector more responsible without burdening each and every occasional player with ever-expanding set of restrictions. Again, due to the travel restrictions, Kim could not be here today, but we have him on the screen. Kim, how are you?
I'm excellent. How are you?
Very well. It's been a long time.
Good to see you. I don't know if you can see my background. I'm in the fitness room at home.
Yes.
It's the room in the house that we use the least, so I'm sure not to be disturbed here.
So you've kept fit during the pandemic here. I hope you're well, Kim. I hope the family is well. The floor is yours, here in Amsterdam and in the webcast.
Thank you, Willem. Thank you for having me or not having me or how you want to see it. Next slide, please. So I'd like to take the opportunity to talk about the artificial intelligence in general and responsible gambling, and obviously also what we do in Mindway. And I'd like to start by saying, it's typical that we think of artificial intelligence as a way or a means of identifying problem gamblers or potential problem gamblers. And that's certainly also what we do with Mindway. But we also use artificial intelligence in many other ways. And one way in particular is that we use it to better understand the dialogue and better interact with the customer. And we have actually a gamification of a typical self-test. So we essentially turn this typical self-assessment schemes into an AI system, and we have gamified that. And we also use actually artificial intelligence in trying to reinforce more positive behavior with customers at operators. So we actually use artificial intelligence in many different ways, not just detection. But let's start by taking a look at the detection bit. So please take the next slide. Actually, I would like to go to slide number 6. Slide number 6, please. It's the one with the blue background. Yes, thank you. So I would actually like to start by questioning, artificial intelligence in a nutshell, or artificial intelligence per se. How much can that actually do? So that's what we typically hear from operators and see happening in the field. That there's kind of a belief that if we can just introduce artificial intelligence, then that's sort of a solution that will solve every problem we have. At the end of the day, however, artificial intelligence is actually nothing more than advanced statistics. And so it all lies in the target, it all lies in how we are utilizing this technology, because otherwise we're really just still using statistics. So that's one thing that artificial intelligence can do that we couldn't really do with traditional statistics. And I know this because I'm also trained as a statistician. If you take the next slide, please. Then the basic premise here is that with artificial intelligence, we can take more complex data than we could previously. So we don't have to really digest the data so much any longer. We can just put in pretty much raw data. So, deep learning, convolutional neural networks, artificial intelligence, these sort of technologies have had tremendous success, for instance, with images. So you can take an image, which is a relatively complex set of data, and then you can put it in more or less as raw. And then if you know what this, if a human can basically say what's on this image, well, then we can teach the AI, we can train the AI to come up with the same response. So if we have a good target for the AI, then we can get a lot of value from it. If you take the next slide, then the problem is in responsible gambling, we do have the data, but we don't really have a clear target. And that's really the big issue here, that we have a powerful technology, but the value really comes from applying it in the right way. Next slide, please. Because at the end of the day, if we don't have a good target, then that means that we are actually not moving far beyond just the rule-based systems that we also know that most operators were applying at least some years ago. So a rule-based system, is sort of a thresholding-based system that gives some rules and some indications for where the problem gamblers are most likely. And with artificial intelligence, if we're doing the same, well, we get a more funky, decision boundary, you could call it, but we're not really per se gaining so much. Now, in response to that, so since we don't have such a clear target, people have tried to come up with different, you could call them proxy markers, different, things we could put in place for a better target. Now, on the next slide, you can see that, many, and just let's get the animations in there. So press a few more times, please. So people have been using self-exclusion as a proxy marker, and self-exclusion, is certainly a strong tool, and it should definitely be in the toolbox for an operator. But we also know that it's only about 20% of self-defined problem gamblers who are actually using self-exclusion. So that means that an AI that's trained on such a system or such data here will actually underestimate the number of problem gamblers. So we're simply going to miss out on people this way. And also vice versa, it's only about 30% of people who use self-exclusion who use this tool because they believe that they are becoming problem gamblers. So that's going to create a lot of bias and even confusion in such an AI algorithm. Now, what we're doing is that we're actually borrowing an idea from radiology and from the hospital setting, where if you have symptoms and you are concerned that this might be a disease, it's natural to go to a general practitioner who can then sort of synthesize this information and come up with an assessment. Similarly, if you have a radiological examinations in an MR or CT scanner, you would have a radiologist basically screen through the data. Now, we're taking this idea and basically promoting this for responsible gambling. Next slide, please. So essentially, what we're doing here, and please forward a bit so we get all the information. Yes. So what we do is that we try to go beyond the traditional markers of harm, and then instead we have a number of experts. So these are not radiologists, obviously, but these are psychologists and researchers and even clinicians who take a look at a very detailed look at customer information. So they basically look at, in our case, 3 months of data, and they look at this pretty much at spin level. And that actually gives them a very good opportunity for assessing whether they see any signs that would be consistent with the development or existence of problem gambling behavior. So instead of having these sort of general rules that apply to a population, then we ask the experts to sort of one by one take a look at individual customers, take a look at the raw data, and then come to a conclusion whether they see something problematic in this behavior. Next slide, please. And that means that we now have actually a good target for, that was 1 too far. So now we actually do have a very good target for the AI. If we could just go back 1 slide, please. So what we do in practice, could you hit the back button? Maybe it only goes forward. It's fine. So basically what happens is that we establish collaborations with operators around the world. We are in Europe, in the US and other markets. And what we do is that we establish a collaboration with a provider. They give us access in an anonymized fashion to a couple of thousand, typically, customers, and then we send this data off to our international board of experts, and they scrutinize the data and they come up with an assessment based on their experience and knowledge and know-how. Now, this is the data that we're going to train, combining that with our in-house information and in-house modeling. This is what we use to create a tailor-made system for a particular operator to best identify signs of problem gambling in their database. And that's essentially what you could see on this slide, that now you can imagine that, we have these experts in the box. So we basically have a digital version now that can sift through a database in virtually real time. Next slide, please. Since we now have a target, and I could say here a reasonable target, then we can also ask what's the performance of such a system. So essentially we want to replicate the behavior of human psychologists, human experts, and so we would like to know if we actually replace this expert with the box that we have created, with the AI solution we have created, what would be the performance, what would be the loss, so to speak, compared to actual human inspection. And so you can see here that we can now say that at least 88% of subjects or customers who are manually assessed as problem gamblers, so the ones that the experts come together and in a consensus deemed to be problematic, are also detected by Mindway. and the other way around. So at least, I think it says 87% here, but it's a bit unclear, percent of subjects that are detected with our software can also be confirmed by the experts. And now we come, as many of you probably know, from a strong research tradition, and we are sort of used to, publicizing our results and also being very open about, our technologies and giving other, parties an opportunity to inspect our results. And as you can see on the next slide, what we have done recently is that we have asked GLI, Gaming Laboratories International, to actually validate these performance claims. So we have simply, in this collaboration, we have set forth a number of claims. Some of them were the one you saw on the previous slide. And then we have made available our code, and we have also made available expert assessments from data from a particular operator. And DLI has then validated that these performance claims are indeed valid. So that's a way for us to, have a third independent party have a look at, our code and our results and come up with a validation. So this is something that we are very proud of and very happy of. Moreover, if you take the next slide, what we have also done is that we are running studies now where we are trying to understand, what's the inter-rater reliability and what's the intra-rater reliability, and also consistency across operators that we're working with. And what we can see is that, we in our experience now, the performance measures that we have just disclosed actually hold up across operators, and they also hold up against raters and inter-rater reliability and so on. So a very high degree of consistency across operators and across raters. Next slide, please. So essentially, we now have a solution which essentially has two components. So we have sort of a summary view where you can imagine that based on behavior over time, we can show the statistical distribution, if you will, of problem gamblers and so on in the database. And then we also have on the other end an individual view where we can go in and take a look at individual customers and then understanding their behavior. And one thing that's really important here, as you can see on the next slide, what we're also able to do, next slide please. What we're also able to do is via what we call explainable AI, we're actually able to relay the reason that experts have come to the conclusion that they have, even on the data that they have never seen, so the data that's being analyzed by the AI system. So essentially what the experts do when they analyze the data is that they don't only give a risk score, they also give an explanation for this risk score. And that means that over time, the AI now picks up on these signals and then learns to read not just the risk score, but also the reasoning behind incongruency, you could say, with experts in the field. I know that we don't have that much time left, so I would like to go to slide number 21. That's 2 slides from here, returning to the big picture. So I said in the beginning that we're looking at just as detecting problem gamblers, but we're also looking at, you could say once they're detected, we also want means of interacting with the customer and better understanding, and maybe also better relaying to the customer what is it for a kind of problem that they are facing, because I guess everybody here knows that problem gambling comes in many different types and flavors, and it's important to address this particular type of problem gambling for individuals to better have this dialogue resonate with the end users. If you take the next slide, then in actually doing this, next slide please. In doing this, a self-assessment is, one way to actually do this. So as an operator, you can send out a scheme basically with a number of questions and then asking if the customer feels in control, has brought money, is missing out on social activities and so on. Next slide, please. But the problem is that is typically filtered and it doesn't, properly reflect what's really going on. Next slide, please. So what we have devised is actually a game, and via this game we can actually decode, and it's sort of deeply tied into neural mechanisms where I actually studied the biological basis for problem gambling. So what we have here is essentially a game where we know that certain types of behavior in this game attracts people with problem gambling behavior, and while others typically have patterns on this game that are very different. So we can, in a statistical fashion, in this way, come up and tell exactly whether this is potentially a problem gambler, but also sort of break down the nature of the problem gambling. I would like, in the interest of time here, to skip to slide number 37, please. So this game is one that we have available now. We are having a very great collaboration with Holland Casino, where we are testing and validating these results. And one thing that we have seen, first of all, is that there's a very high degree of adherence here. So when people start the game, they also finish the game. That's something that's been very important to us. It appears so far to be over 85% of people who actually engage in the game who actually also complete it, and get to this result here where we're actually showing two screens. One screen that shows sort of overall what's your risk score based on your behavior. And the next screen is even more interesting because it tells is this because you're sort of overly susceptible, overly sensitive to wins or to losses or to frequencies, so the sort of the speed of the game and so on. And with this information, we can tell this to the customer, also to the operator, obviously, and we can also give very particular advice for the customer how to proceed from here. And compared to a verbal self-test, which typically would say you have a high score and you should consider stopping gambling, I don't think that's a particular good dialogue to engage in. I think what we're doing here with a game that's unbiased and where we can directly communicate with the customer, but also with the operator, is a lot more beneficial.
Okay.
And then the last slide, please. So what we have here is not the full picture. We didn't have time to go into the details also of what we do in terms of brain training and trying to reduce impulsivity using artificial intelligence and neuroscience. But at least we have two other solutions here where we use artificial intelligence and experts to detect problem gambling behavior. And we have a gamified version of the self-test, which is unbiased and gives a much better means of interacting with customers on their terms. So thank you very much. I hope I'm still in due time.
Great, Kim. Thank you very much. We're not ready yet. We have asked everybody to put their questions in Slido, or perhaps here in the room if there's any questions to Kim. If not, let's move to Slido. If you do have a question here in the room, please raise your hand and we'll have a microphone with you in a second. Kim. One question here from Slido. As an operator, how challenging is it to incorporate your solutions in the day-to-day business processes?
That's an excellent question. I'd like to say that we think that this is very easy. So we can essentially host the solution. So everything that's actually needed is that we engage in a collaboration. And the minute that we send a link to the game that the operator can then send to the customer, then we are basically up and running. So it's as simple as this. We can host the solution and we can give operators and their customers access. We can also send back information not only to the end user, but also to the operator and do the statistics and the analysis if that's necessary. Alternatively, we're also happy to tailor these solutions to operators. We have done some of this work also for Holland Casino to make it more their style and feeling, something that we're also very happy to do and to work with operators towards.
Yeah, great. So quite easy summing it up. I think there's no more questions here in Slido, and we're also at the end of the time slot. Kim, thank you very much for joining us, and I guess we'll see you live in Amsterdam at the next event, hopefully. Thank you very much.
Thank you.